CAD/CAM systems allow us to create a virtual object. In this case, we are talking about insoles. So this virtual object will be designed and sometimes even tested on the screen before we actually go to do the physical manufacturing of it. CAD/CAM systems have a lot of important advantages. Mainly, they bring the orthotic workshop into our house or into our studios or into our clinics, because, well, we are doing away with most of the materials and with most of the equipment that we normally use in the lab. So we will not need vacuum formers anymore, we'll not need plaster of Paris. We can work virtually any time of the day without disturbing anyone when we are designing our object or our insole in this case. An important advantage is the accuracy. First of all, there is sub-millimetric accuracy, which means that when you manufacture an orthotic, it can be really accurate to within a fraction of a millimeter, which surpasses the need of our patients in actual fact. So this accuracy is really needed in engineering works. However, our feet, our patients' feet will deform under pressure, and so making this sub-millimetric accuracy most of the time too much, really. Another important advantage is repeatability, which means that if I manufacture the same device over and over again, it will be exactly like the first one, like the one that we have designed. We know that when we manufacture orthoses by hand, these orthoses may not be exact replicas of each other because, well, human nature and human skill may vary. So these are all very important advantages of these CAD/CAM systems. First and foremost, however, in my opinion, CAD/CAM systems also give you a lot of safety. We know about the hazards that we encounter in the lab. When we grind our materials, the dust that is given off, which we can inhale, even though we take a lot of precautions. We know that this material is not biodegradable, so it will be a potential hazard once we inhale it. And with a CAD/CAM system, we will not be inhaling this material, first of all, because once we manufacture the device, it will be in an enclosed area with a vacuum that will extract all the dust. And secondly, we will not need to perform any works on plaster of Paris or other materials such as sanding, which will throw off this dust that can be inhaled. Starting to design and manufacture this device, let us talk a bit about CAD/CAM systems. A CAD/CAM system really is a method, is a way of designing and manufacturing the product that we want. Hopefully the end result will be the same as utilizing other manufacturing techniques. So if we are to see an orthotic or an insole which is designed and manufactured using CAD/CAM, the end result should hopefully be the same as if the orthotic has been manufactured using traditional methods. So the function of the device will not be affected. Basically, like the techniques we use to manufacture orthoses in the traditional way, a CAD/CAM system will need a way of casting, a way of capturing the plantar aspect of the foot. And for this purpose, normally a scanner is used. The scanner, which can be utilized using several different technologies, will capture the three-dimensional image of the foot just as well as if we have casted the foot using plaster of Paris or else even impression foam. One of the methods is to actually scan the impression foam so that we can still use our traditional methods if we wish. So if we want, or if we are very used to working with foam, for example, with impression foam, we can still continue working with impression foam, and then we can scan that impression foam in order to get the 3D model of the foot that we want. For this purpose, for example, here we are seeing a laser scanner. It's actually the laser scanner which we will be using in our own system. A laser scanner works on the principle of a laser light that is projected onto the plantar aspect of the foot in order to produce a point in three-dimensional space. So it has three coordinates, which are x, y, and z, which will tell us the exact points in 3D space where that part of the foot is. Moving the laser beam across the plantar aspect of the foot will provide us with a lot of points, and thus we create what is known as a point cloud. And this point cloud, which will normally consist of thousands or millions of points, when joined together will produce the plantar aspect of the foot. Another technology that is used is known as structured light scanning, in which a projection of a design on the foot is captured by two different cameras, and the deformity of that capture will allow the imaging techniques to produce a 3D image. Or else we can also use what is known as photogrammetry. Photogrammetry, as the name implies, utilizes a series of photographs which will, when combined together, produce a 3D image of the object we want to scan, in this case the foot. And well, there are various commercially available devices. Once we have scanned the foot, the next important component is the software. The software allows us to design, so as the name implies, CAD, computer aided design. It will allow us to design our device, our insole in this case, to our specifications. A very important aspect of this is that we can try out different designs. So in this case we see that there is a plantar metatarsal pad applied. Maybe we can wish to change that to some kind of other padding and see what it looks like, and it can be done without using any materials, without making any noises, and it can be done even in our clinic.